Imagine you're in the backwoods of Tennessee and you wander into a junkyard and you see old refrigerators, cars sort of dismantled, everything just arrayed in a whole mishmash of different parts. And somewhere in the middle of it, you see a brand new, perfect MacBook Air. You open it and it turns on and it functions. And it's unscratched. You say to the owner of the junkyard, "Gee golly, where'd this computer come from?" The fellow looks at you and says, "Oh, well, last night, I don't know if you heard, there was some winds, and winds just kind of scattered stuff around, and their computer was there in the morning." And you say to the man, "You mean it blew a computer in?" No, I didn't blow the computer in, just some parts in the junkyard, just gathered together somehow, by the wind, and it just kind of got together. And you say to the fellow, "Sir, I mean, it's working, and it's a QWERTY keyboard, and the mouse functions." "Yeah, I know it ain't likely to be, but just, a big northeasterner came in last night, blew the parts away, and there we got that damn computer. Not likely to be, but that's how it is." That is a very apt parable to the concept called evolution. People will tell you that without any directing, guiding force, by haphazard, random mutations, the world that we see has come into existence, and the complexity of it just occurred, just so happens to be. And if you think about it, it is far less likely than a wind blowing together the pieces and creating a computer. And I'd like to share with you one observation on that part. A computer doesn't have a brain. All of the functions of a computer happen through software coding. People write the code, and the code tells the computer what to do. In the early stages of computers, they used to measure software programs based on man hours. How many hours would it take to write such a program? 90 hours, 100 hours? As programs became more advanced, no longer sufficient to measure them in hours, but then the system became measured by man years. If we take an entire room full of people and we put them to work on this project, how much time would it take them? It would take 100 man years, a crew of 100 people a year, and that's how they now measure computer programs. And in fact, many programs are in hundreds and hundreds of years. When they sent up the first lunar probe, someone was curious. How much programming went into writing the various softwares that needed to run the systems? You had quite a number of different systems. You had a navigation system, you had a communication systems, flight systems. When they tallied it up, the number was approximately 22,000 man years of coding. Meaning if you took 1,000 people, it would take them 22 years to write it all. No human being could possibly check it all. It took cadres, entire legions of people to write the various parts of it, and the lunar probe was one of the most complex entities that mankind had ever put together. Interestingly, if you were to ask a biologist to compare a human baby to a lunar probe, biologists would tell you there's no basis of comparison. A single cell in the human baby is far more complex than any machine that mankind has ever created. So here's the question. What tells the parts of the baby to do their functions, their jobs? Who wrote the code? What coding is there that tells this cell to divide and become this part of the organ, this cell to do this? What's running the software? Well, as we know, there is something in the human being called DNA. The DNA is the software of the human being. DNA isn't quite visible by humankind. As a matter of fact, the chromosomes which contain the DNA under heavy electron microscopes barely are visible. But that double helix that we know as the genes, the DNA, is what tells the human body what to do, and contained in it is all the coding for the entire body. If you'd like to understand what it entails, there are 46 chromosomes. Each chromosome contains at least 1,000 pages worth of information, and in the human body is this huge, almost small library of information that tells the body what to do. But here's the interesting part. If you were to ask a geneticist to describe the human body, a example would be as follows. Imagine that you have a huge building with 10,000 rooms in it, and each room contains a bookcase. In that bookcase is 46 volumes neatly arranged, and each volume has about 1,000 pages. That would be some basis of comparison to the human body, because every cell in the human body contains the complete DNA instruction manual for the entire body. The human body is not made up of 10,000 rooms. It's not made up of 10,000 cells. It's made up of at least 1,000 million cells. They debate the actual number, but numbers go as high as 37 trillion cells that make up the human body. And every single cell has the full detailed blueprint of the architect how to build the entire body, the liver, the pancreas, the lungs, the entire systems. Every single cell contains all that information. Now, what's very interesting to note is that you and I were once babies, and every baby began from one cell, an egg cell that was fertilized. That cell then divided again, then divided again, and divided again, and again, and again, and again. And here's the interesting part. That initial egg cell had all of the DNA coding of the trillions and trillions of cells that eventually become the complete body. But what's amazing is that that cell, the egg cell, when it divides, it makes a perfect copy of the DNA. Before it divides, it makes a perfect copy. Then it divides into two daughter cells. Each of those daughter cells, before dividing, makes a perfect copy of the DNA. Then it divides, and on and on and on. But we're discussing untold numbers of copies. When I went to make a key recently, I brought the key to the fellow behind the counter, and he said, "Oh, I'm glad you brought the original." Because oftentimes people bring a copy of the original, and when I make a copy of the copy, it doesn't work. You see, each copy loses some fidelity. If you take a newspaper clipping and put it on a Xerox machine, and then you get a copy, and you make a copy of that copy, and that copy you make another copy, by the third or fourth generation, it loses clarity. You almost can't read it. But here's the astonishing part. One egg cell divides, makes a replicate of its DNA, and that makes another generation, one after another, to make the 37 trillion cells, and every single time the DNA is duplicated exactly. As a matter of fact, if it's off with just a little bit of a variation, terrible genetic abnormalities, oftentimes the embryo won't survive. But an exact duplication, time after time after time after time, every single cell in your body containing the 46 chromosomes, and each one containing all the coding for the body. However, that's not exactly 100% correct. Not every single cell in your body has 46 chromosomes. Each human being has one set of cells that only has 23 chromosomes. What are those? I'll explain it to you simply. My wife has red hair. Clearly, I like red hair. When we had our first child, I was overjoyed to see a healthy baby, a young baby girl with red hair. Wonderful. We had our second child. I was also overjoyed, but it wasn't a girl with red hair. It was a boy with blonde hair. Well, okay, still a celebration. We had our third child, a girl with red hair. Wonderful. We had our fourth child, a boy with blonde hair. The next child, a girl with brown hair, and the next child, another girl with brown hair. Wait a minute. Why is it that two parents will have sometimes red hair, sometimes blonde, sometimes green eyes, sometimes blue? Well, it just so happens to be that in each, the father and the mother, there is one set of cells that don't have 46 chromosomes. You see, the man's sperm, the woman's egg, each have 23 chromosomes. If they had 46 and you'd combine it, you'd have the egg now fertilized with 92. You'd have, I guess, a baby with 4 legs and 4 arms. Wouldn't work very well. Just so happens to be that those cells don't split via mitosis, different process. They actually split the chromosomes, and each of those cells have 23. So that when the 23 from the father, 23 from the mother combine, somehow it is that the genes know which one should be recessive, which should be dominant, red hair, blonde hair, and somehow the coding is put together into a new 46 for a perfectly healthy baby, but different than the father, different than the mother, kind of a new combination. Pretty astonishing. Pretty astonishing, but there's one more step to really bring this home. We moved into our home, and our basement was unfinished. My wife and I decided we'd like to finish the basement and be able to use that space effectively. So I hired an architect to plan out where to put the playroom, where to put the office, where to put the bathroom. He sat down with us, described our needs, and a week later he came back to me with a beautifully well laid out plans for the basement. But I had 2 problems. Number 1, I don't know how to read architectural plans. Number 2, even if I did, I'm surely not handy enough to actually finish it. So I hired a contractor whose job it was to read the plans and then have his crew put the walls here, put the various pipings here, and he finished the basement for us. So here's a question. Each cell containing a full, complete instruction manual, not visible by the human eye, so tiny that maybe trails of it can be seen by a 100,000 power electron microscope. But the problem is it's written in genetic coding. Who can read that stuff? And even if you can read it, who's going to build the pancreas, the liver? Who's going to create the chemical cascades? How does it work? Well, it happens to be that's another function of the DNA. The DNA not only provides the coding, it provides the systems to then read it and then create the various chemicals, various enzymes needed to then produce the body. It not only has all the coding needed, has everything needed to then read it and then produce it, and beyond any human being's sight, the human baby forms from one egg cell, dividing and dividing, a perfectly healthy, well baby comes out. And if you'd like to understand how complex that is, let's imagine that our Tennessee rural fellow over there told us that the computer just evolved. And we asked him, okay, great, but Microsoft Word is on there. Who did the programming? And he said, well, listen, it's unlikely, but that's the way things are. The odds of a wind sweeping through a junkyard and putting together a computer and then somehow writing the code somehow isn't very likely. And it's a lot less likely that a human being so complex, so sophisticated could just happen like that. Clearly the work of a great, wise creator, creating the systems, guiding the systems, keeping them doing what they should be doing.